Okay, example 3, the position function of a particle is s equals 2t cubed minus 1.5t squared minus 4t. This t is greater than or equal to 0, sort of was assumed yesterday, but they're just establishing that this problem, the time starts at 0, then we're counting up from that point. If you ever watched a space shuttle launch or some type of rocket launch, you hear them say t minus 10. That's negative 10 seconds before launch. 0 is the launch time. So the experiment would basically start at 0 going on up. Every launch is an experiment. You know, ideally they do what it's supposed to do, but as we've seen in the past, sometimes they don't work. But typically when you're dealing with position time, time equals 0 is the starting point. Question asks, when does the particle reach a velocity of 14 meters per second? So this is just a specific question about velocity. And what we have to get, and what I was trying to give you yesterday, was kind of a feel for how to deal with position velocity, and then we're going to get to acceleration also down the road when we get to higher order derivatives. But the position function, given position and time, and I'm assuming meters per second tells me s is in meters, t is in seconds. All right. I know if I have a position function s of t, that the velocity function is the first derivative of the position function. All right? So I have a position function. I know how to create a velocity function from a position function from yesterday, do the first derivative. So in this case, the velocity function of this particle is going to be the derivative of s, which is going to be 6t squared. 2 times negative 1.5 is negative 3t, and then minus 4. Alright, the question asks, when does the particle reach a velocity of 14 meters per second? This is the velocity at any given time t. I want it to equal 14 meters per second. So set the velocity equal to 14. And I'm looking to solve this equation for t, because t is when it happens. Alright, so we're looking for the t value that actually creates that exact velocity. So if I solve this, I'm going to get, first of all, it's quadratic, so I get equals 0 first. So 6t squared minus 3t minus 18 equals 0. And it is quadratic. I might look at possibly doing the quadratic formula. Before I do the quadratic formula, since it is an equation equal to 0, so it's just a basic equation here, I am allowed to divide everything by 3 and create an equivalent equation. That's equivalent. Be careful that it is an equation at that point. When you get this v of t equals, let's say everything divides, let's say that was 6t squared minus 3t minus 18 right there. If you want to divide everything by 3 at that point, saying v of t equals that, now you're modifying the problem. All right, but the fact that it equals 0, I'm changing all the numbers the same way, that's fine. If I had, let me just show you what I mean in an easy problem. If I have v of t is equal to 6t minus 18, let's say that. That divides by 6, that divides by 6. I've seen people try and do that before. Alright? These aren't the same. I divided by 6, I divided by 6, I have to divide by 6 in that situation. Alright? I'm actually dividing 0 by 3 here to make 0, just it's not noticeable because 0 is still 0, right? But so again, I've seen people get an expression like this as an answer for velocity, and then they, oh, everything divides by the same number, let's do that. Legally, you're not allowed to because you can't divide that also. So leave this as is. If it's a velocity function, you're solving an equation, go ahead and divide if you feel like it. Divide a constant. All right, so 2t squared minus t minus 6 equals 0. That might be factorable. It's not easily factorable, right? So I would probably go to the quadratic formula here. Every time the quadratic formula has that structure, the 3 objects are opposite of b to a. The 2 easy ones, right? B is negative 1, opposite is positive 1, A is 2, 2 times 2 is 4. The hard part, b squared minus 4ac, we usually do that by itself. B squared is going to be 1 minus 4 times A times C. Negative, negative makes positive. 6 times 4 is 24, times 2 is 48, plus 1 is 49.
Isn't that pretty easy?
That one?
Yeah, isn't it just...
But there's a 2 in front.
Yeah, since there's 2 in front of the t squared? Yeah, like if you're thinking t minus 3t plus 2, it would be, but yeah, the 2, it actually is factorable. It's really not that difficult to factor, but the quadratic form is going to be a little quicker.
Okay. I didn't even see the t.
Yeah, the factored form would be 2t and t. It's a guess and check way of doing it. and I'd put a 3 here and a 2 here and a minus there and a plus there. That's the factored form.
Okay.
But, you know, if you're really good at factoring, yeah, you can do that really quickly. My guess is we haven't practiced those enough for you to be that quick, so the part of the form is going to be quicker for you probably. So 1 plus or minus the square root of 49, so the square root of 49 is 7. 1 plus 7 is 8. And 1 minus 7 is negative 6. All right, 8 over 4 is equal to 2. Negative 6 over 4 is negative 3 halves, but t is greater than or equal to 0, right?
Mm-hmm.
So the only answer that's going to work for us is 2 seconds. At 2 seconds, when the equation is legally used, the velocity is going to be exactly 14 meters per second. All right? So, again, if they ask you a specific question like that, when will the velocity be this? Find the velocity function, set it equal to the number.
Is that negative 6 over 4?
That is negative 6 over 4, yep. If they could have asked any one of those types of questions yesterday, when is the particle at rest? When does the particle stop? When is it moving in a positive or negative direction? How far does the particle move from this time to that time? You know, that kind of stuff. What's the displacement of the particle over the first 10 seconds? How far does the particle move in the first 10 seconds? Difference between displacement and movement. So any type of question like that, again, you have to translate every one of these questions into, is it about position, is it about velocity, what am I going to do with those functions to make it happen? Those are the types of questions you need to ask yourself when you see these questions. And again, it asked me about velocity, I needed a velocity function. It says when is it 14, so I set it equal to 14 and I worked it out. All right. What is the velocity at 5 seconds? Get the velocity function, substitute the t's with 5. Okay, so, you know, depending on what they ask, you know, you find what information you need and then you use it properly. And again, it's basically getting you a feel for these equations and these types of things here to establish what do I need to find, how am I going to use what I'm finding to get what they're looking for.